Kalabagh salt mine. In this project, we are work on the preliminary design analysis of a salt mine under the supervision of Dr. Zakaimat. Here I am Tahir Mahmood and my co-presenter is Hussain Raza Zaidi with our mentor and supervisor Dr. Zakaimat. First of all, I will show you the location of our project. On the left, you can see the study area in the yellow rectangle, and in the right window, you can see the same location on the geological map. Now here you can see the study area on geological map, and in the legend, it shows the Middle Territory to early Quaternary moles. The study area includes eastern Surgar and Kalabagh hills of the western Salt Range and Trans-Indus ranges northwest of Kalabagh town, Mianwali district, Punjab, Pakistan. These mountain ranges comprise an arcuate mountain belt which represents the southernmost frontal thrust system of the Himalaya. Organic belt in the North Pakistan. Geographically, the study area is bounded by Kohad Plateau, the Salt Range thrust, along with its western analog, the Surgar Fault in the tectonic boundary. Range Putwar and Kohad Plateau in the form of large alcocinous block over the Punjab plain. The Kalabagh Fault zone extends 120 km from southwestern corner of the Salt Range near Kushab. Within the study area, the Kalabagh Fault just exposes the Indian Self sequence underlying by Ecoberian evaporates against the deposits of Indus, forming west verging faults and northwest dipping thrust and normal faults. The exposed stratigraphic sequence in the study area consists of Precambrian to Econ rocks uncomfortably overlain by the Sphalic group rocks, the vicinity of Kalabagh hills and along the trace of Kalabagh fault suggested that the Kalabagh fault is dominantly a strike slip fault over most of its trace except the vicinity of the Kalabagh hills. West of Kalabagh hills, the Kalabagh fault is divisible into 300 meters wide zone incorporating a second order fault, namely Ziyaratpir fault. Within the fault zone, a deep-rooted salt body is migrated up section. The fault zone is believed to be undergoing dominant strike slip deformation of transpositional natural, but the diaphoric flow of the salt and its final extrusion have resulted in the development of Ziyaratpir fault that exhibits a normal sense of movement. It believes that the extension is not crustal extension, but it is rather gravitational collapse, recording the crustal uplift resulting from salt intrusion. As in Salt Range, mostly salt outcrop visible on the surface of the earth, so for our study area, we consider the rock salt outcrop. In this project, we are work on 4 segments of preliminary mine design: rock mass properties, design of opening, pillar design, and ground control. Rock mass properties are required for this project are 7. Number 1, uniaxial compressive strength, compressive and triaxial strength, pillar design, Young's modulus, Poisson ratio, angle of internal friction, and cohesive strength. Due to economic limitation, the company is not spending the money on testing, so we have to go through the alternative ways. If there is another mine in that area surrounded by the similar kind of rock salt bed, their testing value can be used. Another mean is to get our laboratory values from research papers. get the rock salt properties free of cost, first of all, there are universities who perform testing for their research papers and available on online platforms. After reading multiple papers, taken an average value which would give us the good estimating idea for further proceeding in the project. Find the desired rock salt properties using any other method. RockLab software is used in this project. As you can see in the table, there are Hook-Brown classification values are given, Hook-Brown criterion, Mohr Coulomb fit, and rock mass parameters are given.
To estimate the in situ stresses, we have UCS, which is 28.876 megapascal. The specific weight of the rock is 21.28 kilonewton and the overburden is 152.4 meter. So the vertical stress is 3.24 megapascal. The value of the K can be found out with the help of the Poisson ratio, which is 0.538, and the horizontal stress is 1.74 megapascals. For the design of mine opening, the shape we consider is elliptical and the dimension of the opening is 5 meter width and 9.14 meter height. Usually for salt mine, the elliptical shape is considered, while for construction purposes, circular shape of the tunnel is considered. To calculate the stresses around the edge using Kirch equation at point A where theta is equal to 0 degree, the formula of radial normal stress is given, where P is the overburden pressure, K is the horizontal to vertical in situ stress ratio, A is the radius and R is the distance. So our value of the radial normal stress is 0. Similarly, the tangential normal stress has the value of 7.97 megapascal, and similarly the shear stress is also 0. At point P, where the theta is 90 degree, the radial stress is also 0, and also the shear stress is also 0, and the tangential normal stress has the value of 1.98 megapascal. After calculating these stresses around the adit, the factor of safety in wall and crown is given. So the formula of factor of safety is strength to stress ratio. The factor of safety of the wall is 3.62 and the crown factor of safety is 14.58, which shows that our wall and crown are both safe. To conduct the stability assessment, we use the Phase 2D software to analyze the stresses in openings and pillars. The process is done in 4 stages. In stage 1, as you can see, the stress analysis in one opening. In stage 2, the stress assessment in second opening. Similarly, in stage 3, the 3 openings analysis of the stress. And in stage 4, the combined effect of all the 4 openings, which shows that the stresses are minimum and safe. Pillar stress formula is given, where the pillar width is 25 meter and the opening width is 5 meter. The vertical stress is 3.24 megapascal. By putting this value into the formula, the pillar stress is 4.66 megapascal. After that, we calculate the factor of the safety, which is strength to stress, and its value is 6.19, which shows that our pillars are safe. The recovery ratio formula is opening width over opening width plus the pillar width. And the value of the recovery ratio is 0.1667 and the recovery ratio percentage is 16.67%. To control the ground, the hazards of flooding in 1 or 2 levels, as the mine we are working is the salt mine, so when the water enters into the mine, it dissolves the pillar. Due to the dilution of the pillar, the strength of the pillar decreases and the stresses on the pillar increases. Due to the increase in the pillar stress, there is a chance that our pillar fails. Due to the pillar failure, the production of the mine has stopped and the mine collapses. The pillar mainly fails due to horizontal stresses. To avoid the failure, we should proceed parallel to the horizontal stress. If there is some indication that our one pillar is failed, the first remedial method is to fill the gap. And if the expansion of the crack does not stop, then we have to do the bolting to stop the crack expansion. And after bolting, we have to install the monitoring devices to monitor it that the crack expansion proceeded further or not. And if the crack expanded, then there is a solution like backfilling or artificial pillar construction or supporting wall that can take on the time without the major failure. So here are some references that we have used to solve this design task problem.